Hello, we are going to be doing skill 2.2, which is the measures of how spread out the data is. So we don't only care about what the measures of the center is, but we also care about the things that are away from the center. And there's some very nice visualizations that we have. We could use things like histograms. This is an upside down histogram, box and beard plot. And the box and whisker plot, though, I would say is probably going to be one of your most commonly used visuals to show how spread out the data is. And you might find some of these graphics to be useful when you do your statistics project tomorrow. All right, so real simple here. The first type of spread that you talked about is range. So this is simply the highest value minus your lowest value. And then we have what's called an interquartile range. So an interquartile range is simply known as Q3 minus Q1. So note Q1 is 25th percentile. Q2 is 50th percentile. Median. We just call it the median usually and not Q2. And then Q3 is the 75th percentile. So if you apply to a college and you look at the college guidebooks and see that the SAT score range is like from 500 to 600, that means that the middle 50% of students are getting between a 500 and a 600. So we might want to think about which one has more spread to it. So that's going to be your first type of delta math exercise here. You might want to just look at the range. So on this one, the range is going to be 90 minus 78. So it's going to get you a spread or a range of 12. Versus on this one, we have a range of 88 minus 71. So that's going to be 17. So we could say that data set I is more spread out than data set H. Another type of exercise that you'll see here is table data on Delta Math. And they will take advantage of also having you do things like compute the mean. So what we could kind of look at here, we could just add up and do the means first. So I'm just going to add up all my things in N. And I just have my calculator right now on my cell phone. You could just use your Delta Math calculator as well. So I have 587 for my total divided by 5. Making our mean 117.4. And they'll try to keep you with a reasonable amount of data so that you don't have to be on your calculators all day. When you have lots of data in the real world, they'll have a computer program, but it is important to know how it's computed. And then this is 416 divided by 5. So that's going to be about 83.2. And we could say that the mean of data set N is greater than the mean of data set O. And then we can also look at the range as well. So this is 197 minus 21. So that's 176. versus on data set O, we have a 135 minus 16. So I can already tell you that the range is going to be greater with data set N as well. But we'll just put both those numbers and we can compare them side by side. And there'll be a drop down menu for you to put greater than on that delta math problem. I'm also going to have you do a little bit of analysis of box and whisker plots. So the interquartile range simply asks us how wide is the box? So I can kind of look at the number here. So this looks like it's about 70. And this looks like it's about 15. So I'm just going to do 70 minus 15. And that's going to get you to 55 for that IQR. And I will say what is kind of nice about IQR is if you kind of have like extreme data. I know this week we are going to be in the midst of record highs. So that's what we kind of mean by like an outlier. But interquartile ranges are less affected by outlier and kind of give you more of like how wide, you know, kind of that average range is going to be. We may give you a question like what percentage of data values are between 69 and 72. One thing that's kind of nice here is that each whisker and each box part are 25%. That's what makes these box and whisker plots particularly nice. And we could see just by doing that, it pretty much answered its own question. So that would be like, you know, the final answer for that. So we'll give you a few box and whisker plots to kind of analyze. And in later statistics courses, you'll learn about things called like standard deviation if you go on and take those. I would be happy to explain to you about what standard deviation is in a breakout room if you are curious. So thank you for listening in and have fun crunching the data.